Hi. I'd like to say a little bit about wood and why I think timber is the building material of the future, and why we're going to see soon our skylines dotted with skyscrapers of wood. And I think we'll see this in the next decade or so. The goal is to replace steel and reinforced concrete towers like these, which are going up all over the world, with a more sustainable alternative. Why? Well, concrete contributes 8% to the global carbon dioxide, and it's the second most used material in the world after water. So I think we can do this with a renewable resource, and timber is an excellent opportunity. It's also the first time in over 150 years that we've had the opportunity to use a new structural material since the advent of reinforced concrete. I'd like to turn to the past, which might seem an odd way to talk about the future of construction, but King's College Chapel is an incredible fusion of architecture, engineering, geometry, space, light, and acoustics. The medieval stonemasons who built this incredible building knew exactly what they were doing because they used their stone material very well. And we would struggle to do the same in stone again today. But if you look carefully, the triangular roof is actually made of timber. And it's that timber that's helped protect it for over 500 years. And in fact, almost every heritage building in the UK that's over 200 years old has a very significant timber component. We've been building with timber for thousands of years, and if we look after it well, it will last as long as we want it to. And we have an opportunity with a new generation of engineered timber materials to do something creative and different. One of these materials is cross-laminated timber, which is essentially very large plywood made out of small pieces of wood like the 2x4s that you might buy at a DIY store. Except that it's larger, it's more consistent, it's bigger than a tree, and it's stronger than a tree. I want to move away from the 20th century, the heroic age of refining steel and concrete into the materials that we built our cities with, and move toward a future where we can grow the materials. I think we can turn the page to a building tradition in which what we build with is grown, not mined. So what do these buildings of the future look like? Well, they might look like this: the Oakwood Tower, a design research project that's 300 meters tall, set within the Barbican estate in central London, designed with practicing engineers and architects to help understand what these buildings might look like. Or this, the Lodge in the Netherlands, another design experiment to try and understand what expressive tall timbers might look like and how economical they would be. But for now, the tallest timber towers of the future look like Murray Grove, which in 2007, when it was completed, was the tallest residential timber building in the world at 9 stories in London. Or Trea in Bergen, Norway, which at 49 meters was the tallest timber building for a while. And like it, there is Brock Commons in Canada at the University of British Columbia. And recently, the tallest timber building was completed in Norway at 85 meters tall. And what do these buildings all have in common? Well, they're exactly the same scale as this building, the Home Insurance Building of 1885 in Chicago by William LeBaron Jenney. This was the first steel-framed skyscraper, and it was with that one idea of using a steel frame to support tall buildings. We went from this building in the late 19th century to the 381 meters of the Empire State Building in 1931. With today's biochemistry, chemistry, materials design, architecture, engineering, I think we can do the same in timber and look forward to architecture and engineering that reaches to the sky. But if we're going to do something radically new in the built environment, we have to do it ethically. We have a responsibility to the people and the planet. And whenever I talk about timber buildings, people generally ask me 2 things. They ask me about fire, and they ask me about the forests. So, yes, timber burns, and many of our great cities have burned. The Great Fire in London is burned in our memory, as is that of Chicago and San Francisco. But the wood that those buildings were made of was wood framing, those smaller pieces of wood, which to a very large fire looked like kindling. The engineered wood of today is much more like a tree. It's on the scale of the trunk of a tree, like this giant sequoia. And wood actually has a natural fireproof mechanism built into it. As wood burns, the charcoal is very, very insulating, and it protects the unburned wood underneath. And you can see that. This tree survived a forest fire in the scar on the upper right and continued to grow afterwards. Of course, there's much more we need to learn and understand about how tall buildings perform in fire, in wood and other materials, but I'm confident that we can build these buildings safely. And what about the forests? Well, my daughters always say, well, Daddy, aren't you cutting down all the trees? Well, yes, I am. But these are trees that are planted as crops. They're planted to be cut down, just like wheat or hay. But we cut them down on the human generation, so we don't experience the full life cycle of the plant. And every time we cut one tree down, we plant 2 trees in its place. Of course, deforestation is a global and urgent problem, but most deforestation is a result of clearing land for agriculture rather than for building materials. And the sustainable forests in Europe have expanded by over 10% in the last 2 decades, which is an area larger than the size of Portugal. So, in order to build an apartment for a family of 3 or 4, you need about 30 cubic meters of timber. How much timber is there available? Well, in Canada alone, every year, they have the capacity to harvest 220 million cubic meters of timber. Over a lifetime, say 70 years, that's 15 billion cubic meters of timber. Human lifetime is the same as a building's lifetime, so that's actually enough wood to house 1 billion people, at least, in perpetuity, forever. And we have to do this, we have to manage the forests sustainably. This is looking after them now and for the future. It's looking after the watersheds, the ecosystems, the trees, the animals, valuing them not just for what they can produce when we cut them down, but what they offer to the people and planet throughout their lifetime. Now, of course, processing wood takes energy, and where does that come from? Well, wood has to be kiln dried so that it doesn't twist or rot, and that takes a lot of energy. But luckily, most of that energy comes from the branches and the sawdust, the bits of the trees that we don't use. So the biofuel for that part of the process is basically carbon neutral. And this is before we account for the fact that every ton of wood holds 1.8 tons of carbon dioxide. So it's a natural way that we can sequester carbon dioxide from the atmosphere for the future. So what might these buildings look like? I'd like to tell you about 2 of our research projects. The first, as I said, is sited in the Barbican in central London, a post-war concrete estate in which we decided to put a 300-meter tower in the garden. This tower rises amongst the concrete towers of the Barbican, and it's on a scale that we've never built with before. So if we use what we know about buildings today, this is engineered so that it stands up. But the columns at the base of this building are 2.5 meters on a side of solid timber. So that's wider than my outstretched arms of wood. Now, no one's ever done that before, but we actually do that all the time in concrete. So what does that look like? We have to turn to the laboratory to understand how the wood performs as it gets bigger and bigger, and we get to bend and break it. And this piece of wood, when we put it in our largest press, we can figure out exactly how strong it is in theory. In fact, we can't figure out how strong it is because it's stronger than that press, which can put 500 tons of pressure on the wood. So with that relatively small piece of wood, we can show that we can hold up a tremendous amount of building. This allows architects and engineers to think of construction in new ways. This is the River Beach Tower in Chicago, designed as a residential building that rises 250 meters above the Chicago River. Using wood is very different from using concrete. Wood is much lighter, typically 4 times lighter. So if you're in a crowded city like London and you take down a 10-story building in concrete, you can actually replace it with a 40-story building in timber using exactly the same foundations, saving time, saving money, and saving emissions. And these buildings, timber buildings, the material is usually cut and prefabricated in a factory, so they arrive on site flat-packed, much like some furniture that you all know. And that allows us to think of how we might build completely differently. So the River Beach Tower in Chicago would be prefabricated in modules that are 2 stories tall. And as many of you will know, the middle of America is littered with large empty factories, and we could put them back to work as places to build these 2-story components of skyscrapers year-round. And then in the summer construction months, we could float them to these building sites on barges and then lift them with some of the largest cranes available in the United States, component by component, and build these skyscrapers from very large prefabricated elements. So I'd like you to imagine that not too far in the future, you might be in the River Beach Tower looking out over the landscape, maybe not even aware that the material that it's made of was growing once, not too far away. And that when the trees were cut down to build the material, 2 more were planted in its place, allowing the cycle to continue. I see no reason why we can't imagine that wood is the building material of the 21st century, and that the seeds of ideas that we're sowing today, when we look back 20, maybe only 10 years from now, we will be surprised by how far we've come. Thank you.